Page 9 of trigonometry. The angle of depression of town B from town A is 12 degrees. Find the angle of elevation of town A from town B. Okay. The horizontal distance between the towns is 2 kilometers. Find the vertical distance between the towns. Give your answer correct into the nearest meter. Alright, I'm going to redraw this picture to just include the triangle and nothing else. Let's see. So we got A, and we got B, and here's the horizontal. Here's the horizontal. And then we're just going to draw vertical lines to complete triangles here. It says that this is 12 degrees. If this is 12 degrees, then this angle here is also 12 degrees. Okay? If you remember from 9th grade, if you have parallel lines and you cut them, then alternate interior angles are congruent. Okay? Then it says, okay, so it says find the angle of elevation from town A of town A from town B. So like if you look at it up here, it's going to be 12 degrees also, right? So it just happens to be the exact same angle as the angle of depression. The horizontal distance between the towns is 2 kilometers. So the horizontal distance is not this diagonal distance here. It's this distance right there. So the horizontal distance between the towns is 2 kilometers. Find the vertical distance between the towns. Okay, so they want to know this distance. Okay, so it's just a triangle they want us to solve here. We can solve either this bottom triangle in purple, or we can solve this brown triangle. Okay, either one's the same. All right, so let's do the purple triangle. We'll have a right angle, we'll have a 12-degree angle, and we'll have an unknown angle. And then the hypotenuse, we don't know what it is. And the horizontal distance, we know it's 2. And the vertical distance, we would like to know what it is. Okay, so how about if we find a trigonometric relationship between 12 degrees, an adjacent leg of 2, and an opposite leg of unknown. So opposite over adjacent is tangent, so we'll put tangent of 12 degrees equals the opposite, which we don't know yet, it's blank, over adjacent 2. Okay? So the tangent of 12 we can find on our calculator. It's just a number. Tangent of 12 gives us 0.213. So 0.213 equals x over 2. And then we multiply both sides by 2. We get x equals 2 times 0.213. And that gives us 0.425. Okay, so it's 0.425 kilometers vertical distance between the towns. That's kilometers. So if you want to put in meters, you would just multiply by 1,000. You get 425 meters. Okay, that was the last problem for angle of elevation and depression. Now we're going to start talking about how to find out angles and sides of triangles that are not right triangles, because in the real world there's lots of times when the triangles are not right triangles. So we're going to use a technique that you used previously. A couple pages ago you were drawing like isosceles triangles, triangles that have equal sides for 2 sides, and we divided them in half and we made 2 right triangles from them. Well, you can use that technique on any kind of triangle. So if you have a triangle that is not an isosceles triangle, not a right triangle, you could do the same thing. You could like draw a strategic line through them and make 2 right triangles out of a triangle that has no right angles. And then you analyze those 2 triangles separately, and then the orange leg that they share between the 2 makes it possible to use sine and cosine to actually figure out sides and angles of these kind of triangles. Okay, so we're not going to show you how to derive the formulas or anything in math studies, but here are the formulas, okay? And actually these formulas work on right triangles too. If you say that one of the angles is 90 degrees and you put them in the formula, they also work. Okay? All right. So basically what this says is, and you really have to be good at the labeling part now. There's a special relationship between small a and big A, small b and big B, and small c and big C. And that is, C is opposite from C, B is opposite from B, and A is opposite from A. Easy to remember, right? So if we have A, B, and C angles, then the sides, we already know that small b is opposite big B, small a is opposite big A, and small c is opposite big C. So we know that the sides are located like this also. So when you start filling in numbers into law of sines, for example, which this is a relationship which enables you to relate all the angles and sides of a triangle that is not right angled, you know which one is which. Okay. So here, that's just something you need to know to use these rules. Okay, so we're going to use the law of sines, and we are going to figure out, let's see, what do we know? We know this, and we know this. Okay, we want to know this. All right, so this is perfect for law of sines, because law of sines, if you know one of the pairs, one of the opposite pairs, then you can start figuring out the other opposite pairs, as long as you know one of the opposite, or one of the other angles or sides. Okay, so you see, we know this red relationship. So because we know the red relationship, we can figure out this orange relationship. Okay, even though we only know one side of the orange, we can use the 67 degrees to figure out the y. And let me show you why that works. First, we're going to write the equation. We're going to write a over sine of a equals small b over the sine of b. Do you see how this has like three ratios? We only need to use two of them at a time. Okay, so let's say that we're going to call 28 degrees big A, and we're going to call 7 kilometers small a. Okay, and then we're going to call 67 degrees big B, and we're going to call y small b. Now we can like put all the numbers we know. We're going to substitute them in. So I'm going to use eraser and erase the small a, because we're going to put, instead of a, we're going to put 7. I'm going to erase big A, because instead of big A, I'm going to put 28 degrees. And I'm going to erase big B, because instead of big B, I'm going to put 67 degrees. Okay? And then I'm going to put sine 28 and sine 67 into the calculator. So sine 28, 0.469, and sine 67, 0.921. Okay, and then I'm going to multiply both sides by 0.921. 0.921, 0.921, and then that'll give me b equals, so these 921s cancel out, and then I'll have 7 times 0.921 divided by 0.469. I'll just do this on the calculator. 7 times 0.921 divided by 0.469. Make sure you do the divided last so that you don't have to put in parentheses. 13.7. Okay, does that look like a reasonable answer? This side is 7 and this side is 13.7. It looks okay. Okay, so y is equal to b, because we named y, we renamed y to be b. Okay, last one of this page. All right, we're going to have another triangle with no right angles. And let's see, what if we named, oh, they already named it ABC for us. That's convenient. So this is small a side. This is small b side. And so let's see what we know and what we don't know. So we know this, we know this, we know this. So look, we have a special relationship here that we do know completely. And then we can use that to take the 51 degrees and figure out what C is. And it just so happens that C is exactly what we want to know. Okay, so we're going to set up a sine rule, and we're going to use A over big sine of big A equals small c over the sine of 51 degrees. Okay, and a we see is 7.5, so we're going to erase a and we're going to put 7.5. Big A is 32, so we're going to erase big A and we're going to put 32. And oh, I already wrote sine of 51 here. I meant to put sine of c, but you get what I mean. Okay, so sine of 32 we put in the calculator, and we get 0.530, 0.530. And then we have sine of 51, 0.777. Okay, so now we're going to take 0.777, multiply it by both sides, so we'll get 0.777 times 7.5 divided by 0.530. So let's do these multiplications and division. 0.777 times 7.5 divided by 0.530. Oops, I typed that wrong, didn't I? It's 530. Do you know you can do this? Just type over it, fix it. Okay, it gives me 10.995, which is 11, right? So side C is 11. And that looks reasonable, right? Because it looks a little bit longer than 7.5. Sometimes the drawing is not in scale, but in this case, I think they tried to make it in scale. Okay, and then that's it. I'm going to put the next few videos one page per video.